What's up guys, Shawnthebro here, and today we're going to be going over frame data part 2. So in today's episode, we're specifically going to be going over startup, active, and recovery frames and capturing those and sending them to the practice mode HUD. So when you see I come to the game here, I'm in versus, I don't have any of that data on my screen, just like we would expect. However, in the previous episode, in the practice mode, we had set up a new widget called the frame data panel. And so if I skip my stage intros, my character entrances, you see that we have this data displayed to the screen. In the previous episode, we had only covered damage and stun frames. However, we also want to cover startup, active, and recovery frames. So in this case, I have my startup, active, and recovery based on the move that I do. I've actually only set up this one move, but I'm going to set up one live with you so you can see how you can do it for the other moves as well. At the current time, I am actually reading this data from a data table. Now, there's two ways we can get this data, and both are relevant for different reasons, so we have to do them both. Today's episode is going to be the easier of the two, and that's going to be just reading from a data table. So specifically what we need to do is figure out how many startup, active, and recovery frames an animation has on this character, write it down, keep track of it, grab that data, and then display it to the HUD. It's very similar to how we did damage and stun frames, only slightly different. In the next episode related to frame data, I'll show you how to gather this data actually by playing the game and just actually capturing it. So we can capture types of frames, advantages, based on what happens in the game as opposed to a hard-coded value. Again, both of these are important because we have different use cases. For some, we want to be static values that we grab from a data table and display. Others, we want to be dependent on what is going on in the world around our character. I'll get more into that in the next episode on that content. But that's what we'll be covering today. So we'll be able to display the frames to the user. It's going to be very helpful to know how long moves are, commands are, how you could get advantage from them or disadvantage from them. Before we get started on this episode, if you want to get caught up in the series, we're on episode 151 of the fighting game tutorial series. We've come really far from the beginning, and I'm so incredibly excited about how far we've gotten, how much more we are going to be able to do with this series. So if you want to get caught up, the playlist is in the top right corner. Click that, it'll show you everything that we've done to date. Otherwise, if you're just interested in the frame data section, you can go ahead and click this right here in the top right corner. And that is the episode for the frame data part 1, where we initially set up this widget for damage and stun frames. One final thing before we do get started, I would love to give a huge shout out to all my Patreon members and YouTube membership subscribers. Thank you guys for everything you've done, for showing me that wonderful support, all the extra miles that you've gone to give this to me and keep this series going and all my content going. Thank you so much. I really appreciate it. You guys rock, and I am so incredibly grateful. Now let's go ahead and get started with the frame data part 2 episode of the fighting game tutorial. So what we're going to need is a way to capture the startup, active, and recovery frames. Like I said, in this specific episode, this is going to be the frames from the table. But not all of our moves, not all of our commands are going to follow that method. So let's go over how I got this method to work. We're going to go into our structures that we have, and we have an F command detail structure that we set up. And this is different than the code F command structure, remember. This structure is the F command structure. However, it's got a lot more content in here that the game and the characters don't always need to keep track of. We only need to keep track of this when displaying it to the HUD, like in the practice mode, or if we're on a menu like the command list where we can see all the extra data. In this widget, I've now added 3 additional variables: a startup frames integer, active frames integer, and recovery frames integer. So all 3 of these are ints. And it's just simply a count for startup, active, and recovery. Very simple, right? So if you're in the structure, you can click new variable 3 times, make them all ints, and then name them whatever you want. You could just call it startup, active, recovery, doesn't matter. Just make sure you've got them in here. You can keep their defaults as 0. You don't have to change that because 0 is a fine default. There's nothing there, it'll just be 0. And once you do that, we need to also go into our command data. Now, it doesn't matter if you have specific data tables for each character or if you have an overall data table with all your characters in there. Either way is fine. Important part is that you open them up wherever you have attacks and want to change these startup, active, and recovery frames, and you set them in this data table. So as I told you, I actually have only one move that has startup, active, and recovery frames. Now, we're going to add one here. We'll probably add it on the medium attack, but I'll show you how to get these exact values because this is going to be this is more of part of the game design process than anything. We're going to need to balance our moves and make sure that they have the proper startup, active, recovery. Right now, all my animations are very long in terms of frames. A typical fighting game animation may only be a couple frames, like a handful of frames, 10 frames, 20 frames. The majority of mine are well over 100 frames, and so you'll see some pretty large numbers here, whereas typically you might see like 4 startup frames, 3 active frames, 3 recovery frames, or something like that. Some of them are longer, but this is pretty significant just because my animations happen to be longer. Of course, you can trim yours, you can use whatever animations you want, and yours may be a lot smaller. So to set them, it's very simple. You click on the Run the Data table and just change these 3 parameters like we do every other variable in this data table. So that's not hard, and you probably know how to do that. Let's see how to actually grab this appropriate data. So I'm going to go in my mutant anim BP, or I can just go straight to the animation. Doesn't matter how I do it. I just need to get to my animations, and I like looking at the graph to do that because I can see what states or what attacks I want to work on, what commands are where, all that sort of thing. Alright, so for example, my light attack, you've seen this many times, this is my rifle punch. And this is the command that I have the startup, active, and recovery frames on. So I'm going to show you how I got these ones, and then we'll do another move. Like I said, it'll probably be my medium attack, and we'll fill that out and get that displaying on the screen as well. So right now I come in and I have anim notify set up on this attack. I have my rifle punch start. This is where I spawn the proximity hitbox. Now, not every fighting game requires proximity hitboxes, so you may not even have them. If you don't, that's fine too. But you should have an active anim notify, or some point in which you're going to spawn the strike hitbox. That's the one that actually deals damage. So the proximity is the yellow one, the strike is the red one. And then we have an ended anim notify as well, and that is when the hitboxes are cleaned up. We try to go back to, we go to the end of this animation, and then we're going to blend back to idle. So the real important ones here are active and ended. Now, if we look at this at the bottom is your frame count. You also have this text right above your little timeline here that tells you some data about where you're at. So I'm on current 1.27 out of 126 frame. Unreal doesn't really track things in terms of frames. It tracks in terms of seconds and it just does a frame conversion here. So you'll get a lot of like 11.14 and all of this stuff. So it could be a little bit weird when you're looking at it. But here's the important thing. Where your anim notifies are to create the strike hitbox. From the beginning of the animation to where you're creating the strike hitbox, that is your startup. Okay? So any time of the animation before a strike hitbox is spawned and can deal damage to the opponent, that's your startup. So in my case, I selected the startup to be 55 frames because the current frame I was on when that anim notify started is at frame 55. You can look at it down here, but you can also just hover over the anim notify and I'll tell you. 55. So when I go into my data table, I go to my startup frames for that animation and I type in 55. Now, active frames. Active frames are how long, how many frames the strike hitbox is around and can deal damage. Okay? So we start at frame 55, and on rifle punch ended, or your ended anim notify, that is when the hitbox is cleaned up for that one. So we have 55 all the way to here, and this is 92. So you can do 92 minus 55. So if I go into my data table again, You can manually do the math. It's not hard to do, right? But you can also, anytime you don't feel like doing it, or if you have more complex numbers, you can enter an actual equation here, 92 minus 55, and I can get a result. Now, I set these up by eye. I did not actually do that. And so I considered this to be at frame 93 from where I was at, and that was incorrect. It's actually frame 92. So you should definitely do that. You should definitely be more careful than I was and probably actually do the subtraction here, the specific frames. But regardless, the point stands. So my active frames here are 37. That's how long the strike hitbox is out and can deal damage. Now, technically in our game, when we spawn the hitbox, we check collision immediately. And unless we have some certain properties set on our hitbox, we actually don't check collision again after the fact. So if they are to run into it, they won't take damage. That is important to note. We will be covering this in combat flow, because part of combat flow is addressing the different collisions that our hitboxes do in the states they put our characters in. And so we're going to get a little bit of an overhaul and an upgraded system there. So don't stress too much, but realize that right now they can really only be hit if the collision with the hitbox and the character occurs on that same frame. It's not going to actually allow them to take damage 37 frames later in this case. But it will, and so we still want to set it up in preparation for that. Okay, and lastly we have the recovery frames. So if you take your start frame of your recovery, which again is 92, and in this case we go to the very end, we have frame 126. And so we can do this, we can do 126 minus 92 and get your result of the recovery frame. So again, if I'm not eyeballing it, I'm using the actual values, I get 34 recovery frames. So these are my final results for this animation. Now, the downside to these hard-coded values is when that animation changes, I have to change these values on here. And even now, these values aren't completely correct because there are a few things at play here. So first of all, if we go from idle to light attack, okay, I actually have blend settings on. If I go to, this is the idle to light attack transition, okay, I have a blend duration of 0.2. So it kind of blends these animations together. Blend won't really affect this here. Even though I have a blend duration of 0.2, it does properly skip ahead in the next animation. So if it takes 0.2 seconds to go from idle to light, it's going to start 0.2 seconds into the light animation when reading the timeline. And thus it won't actually screw up our frame counter. So we don't have to worry about blend here. If we go to light attack, if we actually go into the animation itself and click on it, I'm playing this at a play rate of 3. Okay, and so it's going to play faster, which technically means it's going to be less frames required to play this animation. So it will kind of change the data in the data table, right? Because it's playing at a faster rate, so you're not going to see all these frames. If you're running the game at a consistent 60 FPS and you speed up the animation, some frames are going to be skipped, and in which case you won't actually have these exact values. So while it's good to be able to have this data here where we can use an animation and then display it on the screen, there are times where we need to accurately grab the data regardless of the changes we make. And that is where the next episode is going to come in, where we grab that data automatically based on what the move's doing. But with that said, there are still cases where we'll actually want to use the data table data over the actual animation data. So you'll see where it all comes together, why both of these are important. Now with this done, we actually have our light attack finished and set up. Alright, so now with all that out of the way, we have our frame set up in our data table for at least one of our moves. That's the important part. You can go ahead and do it for all your moves and all your commands now if you want, or just focus on one. We need to go into the code. And specifically, we're going to go to our fighter template character.h, or basically our base character.h. We go ahead and scroll down. We can go ahead and make new variables for each one of these values to be tracked. Now, we don't actually have to track these. You could just update the widget and be done with it. We could just update the widget alone, but it could be useful to keep this data so that we know how many startup, active, and recovery frames were on a specific command, specific move, and display it to the user. Instead of just grabbing it from the command and changing that data, the character can keep track of it. And this way, we can do simple operations, simple binds to just store this data, display it when we want to, and use it for things like advantages, disadvantages. So we can go ahead and make 3 variables. I made them all the same, where they're uProperty, edit anywhere, blueprint, read write with category of frame data. And they're 3 integers, and they are last startup frames, last active frames, and last recovery frames. And they're just going to store that data from the last command that was used. So once you make these 3 variables, you can go ahead and go into your CPP file and your constructor where we set all of the other variables. And I put them right next to damage received and last damage received and last stun frames received. And I set the last startup, last active, last recovery frames to default to 0. That's not actually all we have to do, because we need to be able to gather the information from the data table about the last command. And to do that, I'm going to make a new function. I'm going to make a blueprint implementable event that we call in the character. Whenever we call start command, we're going to trigger this other function, gather command data from table. So basically this function is going to gather extra data about the command that's not stored in the character's command array, but rather only on the data table. If we need it at runtime, like for these frames, we're only going to need this in the practice, not all the time. So we should differentiate when that data is being set. But for now, it doesn't matter too much. The important point is that we're just grabbing the data from the table whenever a command is used. I actually messed up this comment. I'm going to change it. Should say, gather extra data about a command using the command's index. A few episodes ago in the series, we set up commands as not being set in the class defaults of the characters, but actually coming from the data table. So if we go to our mutant BP, for example, we were in begin play calling this update character commands function, passing in a data table, and then we were going into our base character blueprint and grabbing all the appropriate data about these commands and adding it to the character commands array. So at this point, we know that the character commands array is in the same order as the data table is, in which case we can pass in an index of a command that we find within the character commands array, and we will be able to gather the appropriate data from the data table that we have here. So this is a really nice mapping system. If we ever do have to pull data out of the data table, and we don't want to typically store all that data on the command every time, such as the startup, active, and recovery frames, we can go ahead and just grab it using that index. If we go back to this guy and we take a look at how we set this up, we make it a U-function blueprint implementable event, which means we can call it in code and access the data in the blueprint, handle the event, do all the logic in the blueprint. I called it void gather command data from table, and I passed in an integer of command index. Now, since it's a blueprint implementable event, we don't have to give it any sort of body in the CPP, so we can just call it wherever we want. So let's say we go into fighter template character.cpp, and let's go down to our start command function. Start command is a function we have when we're ready to perform a command because the player has pressed the appropriate inputs to perform that command. Right? They've met all the proper conditions. So we go in, we set the character command's current command to say, yep, we've used this command, and that's how we trigger the animation and do a few other things as well. Well, right below doing that, I've now called this new function that we have, gather command data from table, and for the index, I passed in current command. Notice what current command is. It is the index of the for loop here. So the current command we're in within the character commands array while looping through it, that's the index of the command that we're triggering, and that's the index of the command we want to gather the startup, active, and recovery frames for. A few episodes ago, I showed you that we could have data tables in our editor that have different ways of setting it up. So we could have either all of the commands for the entire game in one data table, with this character class being set to the appropriate class, such as mutant. Alternatively, you can have a separate data table for each character. So just note that if you're using the data table that is for all the actions are in one character, it will be a little bit different. but we are going to be doing it where we have all of the characters have their own data table. And this method will always work for that. Now, so we call this function and pass in the command. We have to now handle this function in an event in the blueprint. So what I would recommend is that you handle this event in the individual blueprints, or you do what we did for update character commands, because this function is being called in the fighter template character, which means it can be handled directly on base character BP. However, if you do it directly from base character BP, you have to pass a data table to grab the appropriate values. We did not pass a data table, and as such, we will not be able to grab the data from the appropriate data table. We'll have to manually give one. So if you want to do it in your mutant BP, if you want to copy this logic and do it in all your code classes, you can just handle the event directly in the mutant blueprint, like this. We just search for the name of whatever we called it. I called it event gather command data from table. And it'll pop up right like this. But then we manually have to enter data tables when we're accessing data from them. So alternatively, what you could do is have a function here that calls this. We grab the command index and we pass a data table along. While doing this voiceover though, I decided something was even more convenient. Alright guys, I had to cut a part out because the engine decided that it did not want to stay open and wanted to crash. So I've reopened the editor, and now we are here where we have our mutant BP, we have our event gather command data from table. And I was just mentioning you could set that up. You can grab this event just by typing in event and then the name of the event. So event gather command data from table is what I called it in the code, and so that's what I'd search up in the mutant BP. You could also do it in the base character BP. But for the easiest experience, since this logic is going to require us to use a data table, and I know we haven't covered this logic yet, I'll cover it in a second. What I'm actually going to do is capture this event in each character and then pass along the data table with it and call a separate event within the base character BP. This is very similar how we did update character commands. If you look in mutant BP, begin play called update character commands here, and we passed in the data table related to this character so that we could have the logic all in one place using a parameter we passed in, and base character BP could handle it. I'd like to mimic that type of logic. So instead of doing what I did here, actually, what I'm going to do is, for convenience, I'm going to copy my logic that I have in mutant BP here and paste it in base character BP. You don't have to worry about too much what I'm doing. I'm just showing you this live so you can get my actual idea here, because sometimes the idea and thought process behind the logic is more important than the actual logic. Okay, so I decided while I was doing it that this would be a better way, and I just wanted to show you that we're going to change it. We're going to improve it. And then that's completely normal. So let's go to our mutant BP or any of your children BPs, and let's take a look at what we're going to do. I'm actually going to take out what I have in here right now. Okay, so if you go to your character blueprint, just handle this event like we talked about. And what I'm going to do now is I'm going to have a function in the base character blueprint that is going to be able to do this logic here. Let's have no event handler in our base character BP for the function we made in code, okay? So gather command data from table is only going to be handled within the children classes. Instead, we're going to right click and make a new event in our base character BP. And this is going to be get data from table. We can just call it get data from table, to be honest. If we want to be more accurate, we could probably say get frame data from table. All right, and we're going to have an event in our base character blueprint. Now, before we go into any of the actual logic we're going to be doing in here, let's add an input parameter, and we want it to be of a type of the data table. So if you add a new input parameter, make it data table object reference. All right. Then we can call this data table reference. It's very similar how we did update character commands. And actually, let's stay consistent. So let's say data table to reference. Okay, let's stay consistent. Now, another parameter we need is that current index that we had, right? We passed the command index to this event. We need to get it to the base character BP as well. So I'm going to make a new parameter that is an integer, and we'll call it command index. So this is what our event in the base character blueprint should look like. Get frame data from table should have a data table to reference and a command index. Now, in the children blueprints, the gather command data from table only has command index. So what we're going to do is call our base character BP's event that we just made, which is get frame data from table. And we're going to pass in the command index. Now here, we know that if this is a mutant BP, it should be using the mutant BP or the mutant command data. So we're going to manually set that data table to reference. Now, when we come into the base character, both these parameters are set. So I can just pass in a command index and pass in data tables to reference for this upcoming logic. Before we go any further, so it's not confusing, just make sure that you have this hooked up. The event that we call from code in start command gets captured in the children blueprints, not the base character BP. Then we go ahead and call this new event that we made within the base character BP and pass along the appropriate data. This makes it so the base character blueprint can handle all the logic while the children blueprints can still pass along the appropriate data, since we're using different data tables for each character. Now this system will work for every character that we have in the game and every character we add, making our lives a lot easier. Anyway, with that out of the way, let's go ahead and set up this function now. So get frame data from table. What we're really trying to do is get the data of a specific column, row and column, from a data table. Or for a specific command, however you want to think of it. So there's a way we can do it that we haven't done before. You've seen us do like get all data table rows. We can do something called get data table column as string. And what it will do is it will take in a data table. You can manually put it in like I was, or you can just use our fancy new data table to reference variable so that it works for all characters. In this case, it is going to be the mutant command data. And we type in a property name. So we type in the name of the column within the data table that we're trying to grab. So if I go to my mutant command data, I have columns of startup frames, active frames, and recovery frames. We need to grab all three. In this case, I want startup frames. So I literally type in startup frames. Make sure it matches the case and the spacing and all that directly. All right, at this point it returns an array that has every single value within the startup frames, active frames, recovery frames. But we don't want every single value in here. Otherwise it would read 55, 0, 0, 0, 0, 0. And we don't want all that. Instead, what we want is to just grab the index that we care about. As I mentioned earlier, our commands are now in the same order as they are in the data table. So if we just take our command index and get a copy, this is going to get us the specific value for that command. Okay? So here's where we're at. This is what we've got. Now we can take this value and set it directly to last startup frames. Now it's a little tricky to do this because a string is an integer, right? But we can easily convert it. It's actually very simple. If we just type in the name of the variable we want to set, like last startup frames, and set it, we can pass the string result directly into the integer and it will convert for you using this node. And this is the end result. This is how we get our startup frames from the last command. All right. Now, from there, it's very simple what we do. We copy the same logic, but then do it for the last active frames and for the last recovery frames. So we'll do it here together. So we have another get data table column as string. In this case, we were hard coding the data table. Again, we don't want to do that. That's a lot more work. So instead, we should pass in our data table to reference, and I'm just going to add some reroute nodes. Make it look a little bit nicer here. Something like that. And so now we have the data table of whatever character it is, in our case mutant, and our property name should now be active frames, not startup frames. This is going to return all the values in the active frames column. But we're getting the specific index passed into this event, so we know that we're on the right command. And we can set that directly to last active frames. Lastly, you can probably guess what's going to happen, but we have to do recovery frames. And so instead of using the hard-coded data table, we can go ahead and connect it to our data table to reference right here. Okay, so you can see it goes from data table to reference, reroutes to all three of these. We have another get data table column as string, passed in data table, and our new proper name is recovery frames. We have an array that contains all the recovery frames for everything in that column. So it's going to have all of these. We're going to get the specific index that we passed into this event and set it to last recovery frames. And there you go. So now all of our last startup, last active, last recovery frames, they're all going to be set correctly on the character. You can test this, you can debug it, but we're just going to visualize it, so you don't really have to do that if you don't want to. Now that we have that working, let's go into our widget, specifically our frame data panel. This is where we put up the damage, stun frame, startup, active, and recovery frames in the last episode. Well, from here it's pretty straightforward. We are just going to bind all three of these values to the variables we set up. So it's very simple. You click on the text that you want to bind, go over here to the content text section. Here's your default value. If you look to the right of that, you're going to have create binding. Click it, it'll automatically create it for you. And you'll get this node to start. It'll probably have an uglier name than this, like get startup frames text 0 or something. I just right click on them and rename them. So I have get startup frames text, and I'm actually basically doing the exact same thing that we did for get stun frames text. So if you want, you can go ahead and go to get stun frames text from the last episode, copy it, paste it, and then just change your variables. However, I'll go over it once and then show you how I did it for active and recovery frames. So basically, we have a game mode reference in our event graph. It gets the current game mode, casts it to the type that we're using, and sets a reference so we can access it. On our game mode reference, we have player 1 and player 2. Basically, each character, the left and right character. From here, we need to grab the last startup frames variable, and that's what we want to display to this widget. On our HUD, we determine if the widget is for P1 or for P2. If it's for P1, for player 1, we're editing the widget on the left. If it's for player 2, we're editing the widget on the right. That way the data stays consistent for the player that triggered the command. Okay, so we just take player 1 off the game mode reference and we grab our last startup frames variable, and then you just pass it into a return node. Okay, it's very simple. You have return nodes in your binding here, so you can add as many as you want. And if you pass an integer directly into a text, it will do the convert for you to get this to text value that comes up in the middle. So nothing special there. Very simple. Once you get this working, you can go ahead and copy this. You need to make sure both your active and recovery frames also get a binding. So create bindings for each of them, go into the respective functions, and you can paste that logic that you had. The only change we're doing on any of these is changing this variable. The rest of it is the exact same procedure. We're just changing what value we are sending to the HUD. So for get active frames, we want to send last active frames. And finally, for get recovery frames, we want to send last recovery frames. It is literally that simple. And now when we play the game, we will be able to go into practice mode specifically. That's the only mode where this widget exists, or where it is visible at least. And we can come in here and we can perform an action, and you can see that we have our startup, active, and recovery frames displaying on the screen. Like I said, in the next episode on frame data, I'll be showing you how we can get this data automatically through actually just determining how many frames have passed. Anyway, guys, that's all I got for today, so thank you so much for watching. If you enjoyed, please subscribe. Helps me more than you know, and I just really appreciate it. I want to give another quick shout out to my YouTube membership and Patreon supporters and subscribers. Thank you guys again for everything you do. I so grateful, and I just wanted to give you a second shout out, so thank you so much. If you guys had any issues with this tutorial or any of my tutorials, feel free to join the Discord community. It's completely free. There's a link in the description. You can join and I'll be happy to help you out. Anyway, guys, that's all I got, so thank you so much for watching. I'm Shawnthebro, and I'll see you in the next one. Goodbye, guys.